There are countless things that can go wrong with our planet, from massive volcanic eruptions to huge asteroids hurtling towards us. But what if something were to happen that we never expected? What if the Earth suddenly stopped rotating? Would the world as we know it simply end? How would life on Earth continue? Our planet is spinning at an astonishing speed. At the equator, the rotational speed of the Earth is approximately 921 miles per hour, or 1,500 kilometers per hour. It's so fast that if you were on a rocket ship traveling at that speed, you wouldn't feel anything. You might think that the Earth is completely still, and if it suddenly stopped moving, we'd be thrown into outer space. But it turns out the Earth could stop rotating without much consequence. We just need to make sure not to move too fast. The Earth's rotational speed has been slowing down for millions of years, but it'll take many millions more for it to come to a complete stop. If this did happen, there would be some minor inconveniences like long days and nights, shifting tectonic plates and ocean currents, and some major problems like stronger hurricanes and tsunamis. But before we get into the details, let's go back to basics. Why does the Earth rotate? The Earth was formed billions of years ago and has been rotating ever since. This is because when the Earth was a hot ball of gas and dust, it had no defined shape. Gravity caused it to collapse in on itself, causing the angular momentum to increase. As it got closer to its present form, most of the material was concentrated near the equator due to centrifugal force, which is the result of the Earth's rotation. Since then, the Earth has continued to rotate because nothing has altered its momentum. If this changes, either by adding or removing angular momentum, the Earth's rotation would change. Even though it's very unlikely, let's imagine the Earth suddenly stops rotating. The most immediate consequence would be extremely strong winds. Everything on the surface would continue to move forward at 921 miles per hour. But instead of moving sideways, it would continue going forward off to the east. Cars, houses, and people would keep moving forward until they hit something, such as another person or a mountain. When they did, they'd be pushed off their path and sent flying in different directions. The atmosphere would also be affected. Jet streams would form as air masses moved from areas of high pressure near the poles to low pressure near the equator. These winds could reach speeds of over 186 miles per hour. Luckily, after a few weeks, friction between the atmosphere and the Earth's surface would cause these winds to slow down. Now, we haven't even mentioned the most obvious consequence of the Earth stopping, rotating, longer and shorter days. The Earth's rotational speed is what determines the length of a day. If it stops rotating, one side will face the sun for 6 months, and the other will be plunged into darkness for the same amount of time. This would cause extreme temperature changes. The region facing the sun would experience scorching heat. Even places that are usually quite cool, like Alaska and Siberia, would become unbearably hot. On the opposite side of the Earth, temperatures would plummet below zero and water would freeze. Of course, ice caps would form on the Earth's poles, but they would shrink significantly. Warm air from the equator would flow towards the poles, melting the ice caps. Places that are currently located around the Arctic Circle would experience higher temperatures than the North Pole. There would also be some parts of the world that would have almost constant daylight. For example, the northern parts of Norway, Sweden, Finland, and Iceland would see the sun only set a few times a year. The same would happen in the southern hemisphere. Places like Ushuaia, Argentina, Punta Arenas, Chile, and Hobart, Australia would only see the sun set a few times a year. There would also be a few places that would have almost constant daylight. For example, the northern parts of New Zealand and the southern tip of South America. In contrast, places like Oslo and Stockholm would plunge into darkness for several months every winter. If you live in the northern hemisphere, your summers would be hotter and your winters colder. Living in the southern hemisphere would be better, with warmer winters. But the Earth's rotation also affects the duration of the seasons. During the summer, the Earth's northern hemisphere is tilted towards the sun and experiences warmer temperatures. During the winter, the Earth is tilted away from the sun and experiences colder temperatures. As the Earth rotates, the sun rises in the east and sets in the west. Because of this, the Earth receives sunlight on both sides throughout the day. But if the Earth stops rotating, one side will face the sun all day during the summer, and the other side will face away from the sun all day. This means that if you live in the northern hemisphere, your summers will be hotter and your winters colder. Living in the southern hemisphere would be better with warmer winters. But the Earth's rotation doesn't just affect the temperature and length of the days, it also affects the oceans. Due to centrifugal force, the Earth's equatorial bulge causes the Earth to be wider at the equator than at the poles. This makes the oceans bulge out at the equator. However, once the Earth stops rotating, the centrifugal force will no longer be present and the oceans will become flatter. Without the Earth's rotation, the gravitational pull of the moon would also affect the oceans differently, leading to changes in the tides. The moon's gravity causes bulges in the Earth's oceans, which we experience as tides. One of these bulges occurs under the moon itself, while the other occurs on the opposite side of the Earth. If the Earth stops rotating, the side facing away from the moon would no longer experience a bulge, resulting in lower tides. On the other hand, the side facing the moon would experience higher tides. In addition to affecting the tides, the moon's gravity is also responsible for the Earth's axial tilt. Due to the moon's gravitational pull, the Earth's axis is tilted at approximately 23.5 degrees. This tilt causes the Earth to experience seasons. However, without the Earth's rotation, the moon's gravity would have no effect on the tilt, and the Earth's axis would remain upright. This means that the Earth would not experience seasons as it does now. Instead, both hemispheres would receive the same amount of sunlight throughout the year. Earth's rotation also plays a role in protecting us from dangerous space debris. Most of this debris is left over from the launch of rockets and satellites. As these objects travel at high speeds, they pose a risk to the Earth. However, the Earth's rotation helps to protect us by moving any debris out of the atmosphere within a few weeks. If the Earth stops rotating, the debris would begin to fall towards the surface and could cause damage. This could pose a serious threat to human civilization, and it could also cause massive earthquakes. Earthquakes occur when there is a sudden release of energy in the Earth's crust. This energy is stored in rocks along fault lines. The Earth's rotation causes these rocks to accumulate stress, which builds up over time. When the stress is released, the rocks suddenly shift, causing an earthquake. Without the Earth's rotation, the stress would not be released as quickly, and the rocks would not shift suddenly. This means that if the Earth stops rotating, we may experience fewer earthquakes. In conclusion, if the Earth suddenly stops rotating, there would be many significant changes. The most immediate consequence would be strong winds and storms due to the sudden change in momentum. Longer and shorter days would cause extreme temperature changes and affect the seasons. The Earth's oceans would also be affected, causing changes in tides and flattening of the equatorial bulge. The moon's gravity would no longer have an effect on the Earth's tilt, meaning that we would not experience seasons. Additionally, there would be a higher risk of damage from space debris and a decrease in earthquakes. Although some of these changes would have a significant impact on our daily lives, others would be more subtle. It's hard to predict exactly how these changes would affect our planet and its inhabitants.